The national income model may be solved by using matrix algebra. This is done by following the simple steps of transformation. In the first step, we rearrange the variables on the left hand side and constants on the right hand side. Y, C and T are the variables in the system and hence arranged on the left hand side, and I plus G and A are constants and arranged on the right hand side. In the second step, we rewrite all equations in such a way that all variables are included in all the equations, and if a variable is absent, it is given a coefficient of 0. In the third step, we construct matrices and vectors. Thus, matrix of coefficient may be constructed. Let us name the matrix of coefficient as A. Similarly, vector of variables may be constructed as x is equal to y, c, t, and vector of constants may be written as z is equal to I plus g, a, 0. Thus, the three equations have been transformed into a single equation in matrix form as Ax is equal to Z. Here, A is a 3 by 3 matrix, X is a 3 by 1 vector, and Z is a 3 by 1 vector. Therefore, the transformed model is X is equal to A inverse Z. To solve this model, we have to find A inverse. This is the formula for finding A inverse. It must be noted that determinant of A must not be equal to 0. Proceeding to find A inverse, we first find the determinant of A. Since the determinant is not equal to 0, a solution exists. Pause the video for a few seconds and understand how the determinant is calculated. The adjoint matrix of matrix A is obtained by taking the transpose of the cofactor matrix. The cofactor of an element is obtained by the following formula. Cij is equal to minus 1 to the power I plus j into Mij. Here Cij is the cofactor of the element in the ith row and jth column, and Mij is the minor of the element in the ith row and jth column. Minor of an element is found out by striking the row and column in which the element is placed and taking the determinant of the remaining elements. In the example of the national income model, minor of element 1 in the first row and first column of the coefficient matrix is given by the determinant of the remaining elements after striking out the elements in the first row and first column. Now, by using the cofactor formula, the cofactor of the element 1 is 1. The cofactors of the remaining elements of coefficient matrix A is obtained by using the same formula. I would want you to go back and note down all the cofactors. So, this is the cofactor matrix of matrix A that we have just obtained. And adjoint of A is given by transposing the cofactor matrix, that is, by interchanging the rows and columns. Finally, inverse of the matrix A is given by dividing the adjoint of the matrix by the determinant of the matrix. Further, the values of matrix X may be calculated by multiplying the inverse of matrix A with the vector of constants. We finally determine the equilibrium income, equilibrium consumption, and the equilibrium tax for a closed economy. We tried to solve two important problems of an economy by using matrix algebra. First was the market model and second was a national income model. We will try to explore another important application of matrix algebra in the next week.